Hello everyone, welcome to Science 20 and the topic is about Earth. In this section, we'll explore the beginning of Earth. Earth is more than 4 billion years old. Wow, that's a big number. 1 billion equals to 1,000 million. And as we know, 1 million is already a big number. So 4 billion years ago was a very long time. When Earth was first formed, there were no life on Earth. Then, about 3.5 billion years ago, simple microorganisms appeared. They evolved underwater because back then, Earth has an inhospitable environment, and underwater was the best place for life. The temperatures back then were very extreme. The atmosphere was low in oxygen, and land on Earth was not suitable for life. From 4 billion up to 500 million years ago, this was known as the Precambrian era. About 500 million years ago, life on Earth began to evolve more rapidly and more life forms appear. How do we know this? Well, the evidence lies in the fossils discovered in ancient bedrocks. The prehistoric creature you see in the picture are trilobites, and they're fossils. Fossils, such as this, enable scientists to estimate how old things are on Earth. Canada is home to some of the oldest rocks on Earth, and they are mostly in the Canadian Shield. That's the U-shaped landform surrounding Hudson Bay shown on the map. Many of these ancient rock formations are exposed in the Canadian Shield and they are called outcrops. See the picture in lower right corner? That's part of the Canadian Shield in Ontario. This outcrop's cross-section was carved to make a highway. There are Precambrian rocks in Alberta. See those reddish rocks? They are called slave granite. Slave granite are found in the Slave River, home of the Dene indigenous people. These exposed outcrops are about 2 billion years old, making them some of the oldest rocks in Alberta. The map shows slave granite location. It's located at the northernmost border of Alberta. Now that we know how old Earth is, let's discover its structure. As you can see in the cross-section of Earth, it has four basic parts. The outer thin layer is called the crust, and underneath is the mantle. At the center is the outer and inner cores. The crust is very thin compared to the other layers, and it can crack like an eggshell. The mantle is solid, but it can melt, bend, and flow when under pressure. Meanwhile, the inner core is solid and the outer core liquid. As the liquid outer core spins around the solid inner core, a magnetic field is formed. This magnetic field extends beyond and around Earth. We'll discover more about this later. Earth's structure can also be examined in more detail. Its layer can also be divided into lithosphere, asthenosphere, mesosphere, and the cores. The lithosphere, the uppermost layer of Earth, is part crust and part mantle. This layer floats on the asthenosphere, which can melt, bend, and flow. Further into Earth's structure, you'll find mesosphere. And finally, in the center are the outer and inner cores. What you see spewing out of Earth is lava. The mantle, which melts under Earth's crust, pushes its way upwards. While underground, the melted mantle is called magma, and when it spews out onto Earth's surface, it is called lava. As you can see, lava outflows are spectacular. Some tourists get up really close to watch them. Would you dare to do the same? The lithosphere layer is prone to getting cracked and in some cases produces sinkholes. Let's discover how and why this occurs. Have you heard of convection? Well, convection is when something hot rises and then sinks when it cools down. This process repeats again and again as long as there's a continuous supply of heat. And it so happens the mantle has a constant supply of heat. This melting and cooling of the mantle produces a continuous convection under Earth's crust. The push and the pull action is what caused the crust to break apart. The lithosphere layer is broken up into pieces or plates of various sizes called tectonic plates. These plates constantly move, bumping into each other. A common effect we often hear is an earthquake. As a matter of fact, earthquakes occur every day, but because many are so minor, they are largely ignored. If earthquakes were to occur in the sea, it can sometimes produce tsunamis. These huge tidal waves are very destructive when it arrives at coastal areas. Tsunamis are dangerous. It kills people and causes a lot of damage to coastal areas. In the year 1700, before earthquakes were recorded in the northwest coast, a huge tsunami was triggered by a mega earthquake off the coast of Northern California all the way up to BC. It was so big that the tsunami reached across the large expanse of the Pacific Ocean to Japan. On the Oregon coast, you will see stumps like this sticking out of the sandy beach. These are actually remnants of dead trees from the year 1700. Once a lush forest, these trees died because the land sank into the water due to the mega earthquake and the seawater killed them. No records were made of this event happening in the 1700s. Yet, indigenous people of the northwest coast knows about it. How did they know about this event? Well, the event was preserved through indigenous oral tradition, where stories of the past were handed down not by recordings on paper, but by storytelling by elders. From one generation to another, this oral tradition was told and retold to keep the stories alive. For those who are interested, here's a news clipping about the tsunami of 1700. Pause the video if you need more time to read. Here's the last section of the article. Now let's see what we already learned. Fill in the blanks if you have the handout as shown, or write the whole page and complete the sentences. In the next lesson, we'll discover more about Earth's early life. See you. Until then, keep and stay safe with family and friends.